Hi guys, welcome back to Learn Electronics Repair and this amplifier that's stuck in protect mode. So we got somewhere with this in the first part. I won't go through it again, guys, watch it, okay, enough said. So we have a low signal on the diag 2 pin. This is the pin that effectively tells us if one of the protection circuits in the amplifier chip is triggered. What we should get is this signal going high and then pulsing low if the fault triggers. Also, according to the datasheet, we should see that happening before the amplifier starts running, so when you first power up, which explains why the owner tells me that the protect light comes on for a second or so and then goes green in normal operation. So the fact this signal is just stuck low really comes down to three things as far as I can see. One, that the chip is actually holding that signal low. Two, that there's a low resistance or short from that signal to ground. Or three, that the pull up resistors that should hold this signal high at a maximum of 5 volts is not working. That could be an open circuit resistor, it could be a missing 5 volts. Those seem the two most likely reasons anyway. So I want to check, these are the two amplifiers, the diag pins. I want to see if there's a short from here to ground or a low resistance to ground. I also want to know if they're both connected together. So as there's only one protect light, it's possible, I guess, they're both connected together. Let's have a look. Well, I'm on continuity mode. Okay, meter's working. There's no connection to the two, so they're not connected together. These are independent signals. If we go to ohms range, is there any resistance? In fact, no, they just read open circuit, so I don't think they're connected together through some resistor either. This is ground, safety ground. Is there a resistance from here to ground? No, they both read open as well. Meter's definitely working. So there's no resistance to ground pulling them down. I mean, the chip could be holding this signal down. So we're down to, I would think, either some problem with the pull-up resistors, but because they're not connected together, there must be 2 of them, and I can't see there being a problem with 2 of them. That makes some sense, yeah, unless something like catastrophic has happened. The other thought is that the 5 volt supply on this amplifier is missing. There must be a 5 volts or something less. I mean, the datasheet says a maximum of 5. It could be maybe 3.3. I'm not sure what the minimum is, but maybe the datasheet will tell us that. So let's have another look at it. So here is the datasheet. It mentions here that the amplifier has 3 operating modes using the pin modes. So standby mode, mute mode, or operating mode. And that's controlled by the voltage on this pin here. And it shows us, if we look through, yeah, mute mode is 2.2 to 3 volts on this pin. Standby is 0 to 2.2, and then anything above 4.2 is operating. So we should expect to find a voltage on here if it's not in standby. And again, that appears to have a maximum of 5 volts. It does mention it in here somewhere. Yeah, it shows us there's a 5 volt pull-up, an actual fact, that controls this circuit. These switches, I'm not sure, maybe that is a physical switch or standby. It's quite possible that these are MOSFETs rather than physical switches that actually connect from here to ground. Okay, so we can have a look to see what's on mode. If we have no voltage on here either, again, that makes me think this 5 volts might be missing. Mode is on pin 23. Okay, so we can look at the voltage there. We have some more voltages, so pins 18 negative supply, 20 positive supply. This is probably that 37 volts, whatever it is we think we have. Okay, there are some more voltage supplies mentioned, so we may have to just check a few of these pins. Now let's look again at the protection. Yeah, here's the protection. Thermal protection is on diag 1 pin. I'm not too worried about that at the moment, although that was also low. Okay. So diag 1, this is thermal, and it shows this should have a pull-up voltage and should go low if there's a temperature problem. That is just low again. It mentions overcurrent protection. It mentions current limiting behaviour due to low output impedance. Bear in mind we have no speakers attached to this at the moment, so there shouldn't be any output current anyway. It does mention there's an under voltage protection if the supply voltage drops below minimum supply voltage threshold. An unbalanced protection, I think this is if one, yeah, this is if one supply voltage, the positive and negative, is more than 2 times the other one. Okay. And this shows the behavior, so voltage on diag 2 should be, I'm guessing, 5 volts. That's what it says as the maximum. And this shows the behavior of it. These are the pulses it talks about. If you get some sort of current limiting or some sort of error, okay, we can switch the amplifier off. Yes, it says here that the pulse signal on pin diag 2 indicates the amplifier is being switched off by one of the protection circuits. This signal is also generated at startup before the amplifier output starts switching, and we don't see that. We don't see that pulse signal at all. We just see it try to go up a little bit, then it just goes low. One other thing I'll just mention about this data sheet that I spotted that may be involved, but I don't know. It mentions here as well about clock signal. So there's a clock signal that can be provided by an external oscillator connected to pin OSC. Okay. And when this signal is lost or the clock frequency is too low, the amplifier will be switched off and remain off until the signal is restored. And it mentions somewhere else in here, I've already spotted it, that if you have an application like this where there's more than one of these chips, which we have, that the oscillator has to be external so that the 2 chips can synchronize. Otherwise it causes some sort of audio artifacts. So there's another possibility we can look at this, is the oscillator, is it running? So that's the sort of ideas I have so far. Obviously we need to do them in some sort of order. So first of all, let's have a look at the mode pin to see if we get any sort of voltage on that. If we don't, I suspect we have this 5 volts missing, but then it's a matter of figuring out, well, where is it? But we can cross that bridge. If that's the bridge we find. So let's have a look. So this is the mode pin. What do we get? 1.97, 1.98. So there is a voltage on there. The data sheet said about that. Well, according to this, it's in standby. Okay. That suggests the 5 volts is probably there. Okay, next. So we should have supply voltage on 18 and 20. Okay, so this is 6, 8, 10, 12. Well, that's 23, that's 22. This is 20. This one here, just get to it. 37.8. Yeah, that's what we'd expect it to be. And then pin 18 is next to it. So 22, 20, 18 is here. I think it comes to this capacitor. That's the minus supply. We can see it there. And I'll just check on the other one as well, because I'm only checking one at the moment. Standby. Positive supply. Negative supply. So they're both the same. 8 and 11. This is for channel 1. Well, 8 is next to the resistor that I soldered on. That's here. Yeah, 37. 11 is actually next to it. That's this one. Yeah, negative supply. And then there's two more, 13 and 16. I'll do the same on the other one as well. So all the voltage supplies are there to the chips. And we do have that thing in standby for some reason, but maybe, well, according to that circuit, it should start in standby, then that should go upwards with like a kind of a soft start or C network. Okay, so all the voltages seem to be present on these. They're independent on these two diag pins, so whatever's affecting them is affecting both of them. So I need to find some sort of common factor. I was a bit surprised on that mode pin. I thought that might be higher than that because it's just stuck in standby, but there's no standby button on this. There's nothing to sort of put it in standby. So whether that is connected in some way with this problem with the pin 6, I'm not sure. But it's certainly trying to tell me something. I'm just trying to figure out what it's trying to tell me. Well, another thing common to both these amplifiers is the oscillator. This is where I read about the external clock, so I can actually show this to you now. So it's saying that if several Class D amplifiers used in the same application, we should use an external clock. So it says here, okay, it says that when using external clock, it's necessary to force pin OSC to a DC level above signal ground. This disables the internal oscillator, okay. Internal oscillator requires a resistor, or OSC, from OSC to OSC ref. This must be removed when using external one. And it says here also, to get the devices running at the same switching frequency, this can be achieved by connecting the OSC pins together. So let's just have a quick look at that. I suspect that's what we will find. So OSC oscillator is on pin 1 here. Does that go to pin 1? Yeah, that goes to pin 1 on the other one. That's not connecting to ground, is it? No, so we should be able to get a DC voltage on that. And then OSC ref, that's on pin 5. This is where the resistor should go, but it should be disconnected. In fact, it doesn't connect to pin 5. This one. No. So we can have a look to see if we've got anything on pin 1. That'll tell us if the external oscillator is running. I've just tagged the stiff wire on the resistor onto the pin 1, clip my scope probe on. It just means I have my hands free. I find that easier when I'm recording, guys, so I have to handle the cameras and various things, okay. So let's see. Do we have an oscillator or not? Well, it looks like we probably do, because I can see a slope there. Yeah. And it's 694 kilohertz, which is exactly what it said in the data sheet that it would be. So we seem to have everything here apart from this protect signal going off. Let's go back onto it. So I still have one resistor attached on here. Okay. We'll look again. Yeah, there's nothing there. There's definitely nothing there. Okay. Nothing there. That's an interesting puzzle. I'm starting to think now that this whole protection on this diag 2 pin is just a red herring, because if you look from this side of the board, that's the pin. I thought it actually went to this with these wires through the board, but it doesn't. And the same on the other one. So it's not actually connected to anything on this side of the board. I don't think this is a multi-layer board. I think this is, I mean, I could be wrong there actually. I think it's more likely a two-sided board. And if we look on this side, then you can see that pin 6, which is that one down there, it's not clear if that goes anywhere either. It just looks like we have like a ground plane kind of all around here and on that one. So I'm thinking, but I'm only thinking, that maybe that protect isn't used at all and there's some other circuitry on here which is effectively doing the protect mode, which is controlling the standby on the mode, and so therefore it doesn't come out of standby, in which case it wouldn't need that protection. I've had another look at this. So this input here says mute. Okay, although this is not muted, it's in standby, we know that. There's no standby button apart from the on off switch, which is a soft start. So this does have a standby supply, and this effectively just puts it into standby or on. And we know that's working because the protection light comes on or goes out. It doesn't go green. I looked at the manual because I couldn't understand how this mute works. Do we connect some sort of switch to here to put it into mute? It seems a bit strange. So I'll show you what the manual actually says. And it shows it here. So mini jack input 12. And 14 is the stereo RCA input. And it says that if we use the stereo input, this is the mini jack, we can connect to MP3 players, etc., laptops. Plugging a connector into this input mutes the stereo input 14, which is that one. So really what actually happens is, if you plug a jack into here, it disables this input. I think to say it mutes it is a bit of a strange nomenclature, but that's what that is. So this isn't a mute function at all. This is just literally that there'll be little switches in the jack socket here. When you plug a jack in, it disables that. So that doesn't get us anywhere. If we look at the other side of the ribbon, which I should have done a long time ago, we see we have some actual voltages on here. So we have plus and minus 15. Well, we already proved that they're there anyway. That was early on in part 1, so we know that's there. We have limiter. Yeah, it's a limiter signal from the preamp board, the mixer board by the looks of it. We have SW charge, like switch charge, but this thing isn't battery powered or anything, so I'm really not sure what that's supposed to mean at all. Sub, so this will be the output to one of the two amplifier modules. We know from the data sheet it can either be used as a stereo amplifier or as a single bridged amplifier. We can say the sub will be bridged. Then we have right and left, so these are our audio signals coming in. Here's the standby, 7.5 volt standby. This is probably where I was trying to find a 5 volt supply somewhere. So we can look at that one, and then we have mute in, mute out, and switch standby. Okay, so switch standby, we can say I'm pretty sure is this switch. We can measure that and check that. Okay. As regards mute in and mute out, I'm not sure which direction is in and which direction is out, if you know what I mean, is in or out with reference to what? This PCB, the other PCB? That I am a bit unclear. But we can have a look to see what's on these, okay? So let's power this up and let's see what we have. So first of all, I actually have the standby button switched off. And if we go to this one, switch standby, 4.76, switch it on, it goes to ground. So that's just telling us that the standby button is working on the front panel. And now it's grounded, I have the red light on. We go back to it, press the button, back to 4.76. So that is switching the standby. The standby voltage itself, well, we can see it here, 7.5 volt standby here, and we have 7.5 volts. So that, now we know there's a standby supply, will come from the small transformer. I'll just switch it off a moment. So we know we have here, yeah, down there, a small transformer, okay. This must be where the 7.5 comes from. We can have a quick look, but we know it's present. So this is the large transformer, the small one is here. We can see some diodes here. So one of these windings will be the primary. This is the secondary, this is the output. And then the other one is an auxiliary winding that will generate the supply that the controller chip needs to keep running after startup. That's, guys, I think if you watch the channel, you've seen this a lot of times now, so you can recognize what we have. One of these diodes will be providing the power to keep the controller running, and the other one will be part of a snubber network. Okay, that makes sense. So if we look here, we have a diode on the secondary. So this point should be the 7.5 volt standby. This is where it comes from. So we can just power this up. Yeah, 7.5 volts. So that's our standby voltage and it's there. Let's look at these other voltages. So basically, we know what switch standby is. We know 7.5. We have mute in and mute out. So what's on mute in? Let's have a look. Okay. Power on. 13.6. So mute out. $1.987. Is that the same as we've got on the amplifiers on the mode pin? This is what's holding them in standby. Although that says mute out, I think that's the same voltage that I see on pin 23 over here. In fact, it was the same voltage. So let's go to continuity. Yeah, we're on continuity. So I want to go from mute out to pin, yeah, pin 23. So that's what is holding our amplifiers in standby. Now I think this is kind of part of the protection, because we've proved really that the built-in protection isn't being used in these chips. But where's that coming from? Out? Is it coming out from here? Is it going into there? This is a bit strange to me, because logically thinking now, as logical as I can be, whatever's monitoring the supposed fault condition, whether it's a real fault or whether it's a phantom fault, is going to be on this board. I can't see it being in the mixer. I mean, I never say never, but it doesn't make a lot of sense. It makes much more sense it's somewhere on here. So that is what's probably generating this signal. I don't see why you would send the signals up this ribbon cable for this to do the monitoring and send it back. And Det's saying no behind me, I can hear him, and I completely agree. Hey guys, Det's here. So yeah, I think the problem is in here. But the situation I have now is although I know quite a bit about this, is how to diagnose the fault. If one of these chips has a datasheet that says something like protection IC, then that makes some sense. But if these are all just op amps or something like that, I think I'm kind of lost in a rabbit hole of circuitry here, and I can't see an easy way that I would actually diagnose what the problem is. But let's have a look at the datasheets. So what do we have? CD4536. I'll look that one up. TL072. That's an op amp. N5532. I'm sure these are dual op amps because there's plenty of them. They're all the same. Okay, we have some others. Look at those ones. LM13700. See what they are. These are more of these, which I'm pretty sure are just dual op amps. What's that on that one? Just a bit of a, yeah, just a bit of something on that one. Not a problem. There's what looks like a voltage regulator, BCP56, and then we have another chip, CD4047. So let's have a look at some of these chips and see what they are. CD4536 is a programmable timer, okay, so a generic sort of chip. N5532, I'm sure these are going to be dual op amps. Yeah, dual op amp, exactly what I thought. LM13700. Well, general purpose op amps, okay. CD4047, is this an oscillator? I seem to remember this is an oscillator of some sort. Yeah, low power monostable, astable, multi-vibrator, an oscillator. And then we have what looks like a MOSFET or a voltage regulator, BCP56. Which is an NPN transistor. Okay, so that's what we have on the board. So what we have here is a load of op amps, basically a timer chip, an oscillator, a lot of analog circuitry without any information on what this is actually doing. It's not part of the mixer, so we can assume this is some sort of like supervisory circuit, a management circuit. So probably the protection is done in here, although it seems to be quite a lot of it just for that. We know there's an external oscillator somewhere, but that is running. So this comes down to two things really, well, three things. One, I don't think I can actually fix this. I don't have a data sheet for a device that I can actually get to say, well, this can lead me to this or that, because this could be doing anything and I have no information. Okay, I could take my bench power supply and connect it to there via a resistor and force these amplifiers to run by applying more than 3.2 volts, between 3.2 and 4.2 volts. Now, if I do that, what's going to happen? Well, I don't know, but the chances are the protect light won't go out because some circuitry here is controlling that and controlling this. Okay, so A, I don't think it would make it work, so it wouldn't really prove a great deal. And B, the last time I tried something like this was with a 1200 watt ATX power supply, where I could see that there was an open circuit somewhere between the PS on, the green wire coming in from the ATX connector, and the pins on the chip, which effectively controls the pulse width modulator. And it was going through a board I couldn't see. This was a modular thing, so I had two boards sandwiched together, and somewhere on the board in between, it was going onto that board and not coming out. It was measuring open circuit. So I thought, oh, I must have just an open circuit here, and I bridged it, and I pulled it in, and the thing exploded. Yeah, because as somebody rightly commented, nice one, Richard, disabled all the protection circuitry by doing that. And if I put a voltage onto these, I'm basically doing the same thing. I may well force them to run, but am I going to gain anything other than something spectacularly bad happens? Because even if that doesn't happen, I'm no closer to fixing it. That's the thing. So all I think I can do here, and I'm going to do, is just go around all these op amps and diode mode on the inputs, just to see if I can see an obviously faulty op amp chip. If I don't see one, then the chances are that's as far as this is going to go. So here's my multimeter, and we're going to diode mode. To do this, I'll do the dual op amps first because I know the pin out for these. So we take the red lead and we put it onto the negative input, which is pin 4. Okay, just check the polarity of these things. This looks like it's pin 1. Are they all the same way? Yeah, they look like they are. So this is pin 4 here. So I'm going to put the red lead on pin 4, and then I'm going to look on the input. So this is in, out. In, out. This one obviously not being used because the two ins are connected together. And you would normally see on a good one some sort of diode junction here. Yeah. You know, I'm the wrong way around. I can see it now. The lighting's not very good. Right, now I should have done that. So, just typical. This one is mounted the opposite way to the other ones, okay? So let's go again. This looks like it's got an input connected to an output. Oh, that's fair enough. This is just acting as a buffer. So, red lead onto the negative in. What do we have? A diode junction and a different diode junction. But bearing the way that's connected up, it doesn't surprise me. And then from here in. Yeah, 607. 567. So I do effectively see like that diode junction. Let me go to another one. I'll show you a better comparison maybe. So this is the minor supply. So we get diode 586, diode 606, and then an output 606. Go the other side in 642. 606, 606. So 635, 606, 606. So both of the op amps in here read basically the same as each other. I can keep this on here because all these will be connected together. So let's look on here. So 641, is this 606? Yeah. Yeah. 492. I mean, bear in mind there's going to be other circuitry in here as well. What I'm really looking for is like a short circuit somewhere. 492, that means the same as the other one. 718, 618, 709, 714, 619. So I don't see anything that strikes me as being particularly odd. Okay, I mean that's reading lower, but you don't really know exactly what's connected around these. But if I find a blown op amp, it'll probably read open or short. Okay. And I can do the same with the quad op amps. I just need to find a pin out. I can probably take a good guess actually. So I can probably think, on these I wouldn't be surprised if the power's across the middle of them. Let me have a look. Okay, with these it's a dual device. But we can see each side is basically connected the same. So the minus supply hits here on 6. I'll put my red lead here. And then from 1 to 5 and 16 to 12, they should look basically the same side to side. and the same with 10 and 9 and 7 and 8. Let's have a look. So red lead to pin 6, which is there. Try and get a good connection onto this one. Okay. And then I'm expecting 1 on here to look like 1 on there. And the same on the other chip. Yeah. And then the same with 2. Should look the same as here. Should look the same as here. Should look the same as here. So I'll just go through the rest of them. You can see what I'm doing now. If I spot anything obvious, I'll let you know. Okay, I've tested all the dual op amps. I've tested these and I may have found something. I'll show you what I've found, then we can talk about it. So again, we go the positively to the negative input. I'm basically looking for like protection diodes inside these chips. That's what I'm really doing here. So pin 1, 677, other pin 1. Yeah, 683. And then that should be the same as pin 16 and pin 16. So they're all basically the same or close. Pin 2. Read 635, pin 2. 635. And then pin 15. 641. 642. So these similar. Okay, pin 3. Reads 1250. Pin 3. 493. Pin 14. 493. 493. So that pin looks to me like there's a problem. I don't believe these diode junctions are external. I think they're in the chip. It's most likely that's where they are that I'm seeing. Let's go to pin 4. Reads like 1252, 1.252. Pin 4. Diode. Pin 1650, pin 13. Diode, 0.55. Diode. So both those inputs on this one look different from all the others. 3 and 4. What's on 5? 651. 635. Fifth one down. 641. 641. That means the same. Pin 6 is the power. 7 and 8. This is where those transistors were built into these things. All read open or close to open. Okay. The same applies on this side as well. So what it looks like is this chip has a faulty op amp in it. Yeah. And that's the closest I can get to fixing this. There's only one way to find that out yet. I don't think these things will be very expensive. Let's have a look. I won't have any, but I want the small outline IC. That's the wrong chip, but I think we need to put on here is SOIC. SOIC. What we got? That one. That one. 190 for a lot. How many in a lot? Doesn't really matter. More than one. Okay, 160 shipping. So 5 pieces in a lot. Let's order this then. So we'll go to buy it now. So you can see it's 190 and 168. So that's 358. Yeah, 358 added together. Let me show you because I've told you guys about this. Buy now. Look, it's gone to 296. Why? Because I don't pay the VAT. I know exactly how much the taxman didn't rip me off for. That makes me feel real good. Okay. That's one of the things I love about living in the Canary Islands, apart from the weather. Yeah. The scenery. Both mobile and fixed. Yeah. So there's lots of good things about living here. Anyway, guys, I'd be very interested to hear your comments on this repair. What do you think? What do you think my chances are of actually fixing this one based on what I've done? Get down there and tell me. Yeah. I feel okay. A bit ambivalent, but okay with that. So let me know. And I just have to say, thanks for watching. I look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.